Hello, good evening, and welcome to the second talk of today's meetup. And I'm going to talk about end-to-end file encryption in a web browser. Now, this is not about animations. It's about something going on in the background and making stuff secure. So maybe Samuel and me can team up and make something beautiful and secure. That would be cool. I'm Tom. I work for a company called SBA Research, which is a research center for information security. And I work in the software security team, where I do stuff like penetration testing, secure development lifecycle related things. I do also some software development. I have a little pet project, which we use, a web application that we use to exchange sensitive files with our customers, for example. And this is where we encrypt stuff in a web browser. And that's what I'm going to show you, okay, how we do this. I'm also one of the founders of the Sec4Dev conference and bootcamp, which I presented in the beginning. And this is Olivia, our mascot. Cool, so what we'd like to do. We would like to encrypt the files before they are uploaded to the server. So we're not going to upload something via a secure channel and then store it somewhere on the server and encrypt it there or leave it unencrypted there. We want to encrypt stuff before it leaves the browser. So that's the basic requirement. I have to admit, I didn't invent this. Okay? There's a web application called Firefox Send, which is very cool. You can use to exchange files with other people. They use end-to-end file encryption for this purpose. And the basic concepts that I'm going to present in this talk are taken from there. Okay? So if you want to have a look at the source code, a working example source code, you can have a look at this source code because it's basically the same concepts. You can reach it under send.firefox.com. It's really good stuff. So if you want to share stuff securely with your peers, use this. So the requirements. First, I want to ensure confidentiality, integrity, and authenticity. All three things with my files. Not just confidentiality, but also authenticity. So I want, if somebody has the key to a file, only those people are allowed to upload stuff. Okay? Nothing can be manipulated on the way. That's an important requirement. I want to do it in a browser, as I said, not only when it hits the server, but before that. I want to support big files. So I want to upload and download files that are, say, for example, bigger than 10 gigabytes. This is going to be a very important and challenging requirement because I cannot encrypt stuff in the browser all at once because that would use 10 gigabytes times 2 of memory, which we basically usually don't have available in the browser. So that's going to be a big challenge. That's why I stated as a separate requirement here. And we want to support old browsers as well as possible. And I want to find a way to securely distribute keys via a link. So I want to send you guys a link, but I don't want the key part of the link to be sent to the browser because that would break the authenticity and confidentiality requirement again. Okay, so that's the last part. Cool, so let's have a look at the first requirement, confidentiality, integrity, and authenticity. Now, before we go to taking keys to encrypt something, we need to generate keys. And generating keys in a secure way means using a secure random number generator. So randomness is the most important thing here. Do you think this is a random number?
Any number is a random number.
We can't say whether it's a random number or not. Is this a random number?
Sure.
Could be. I don't know. It could be randomly generated. Now, the important thing is there is no such thing as a random number. There are only ways to generate random numbers. A guy called John von Neumann said that in 1961, so pretty long time ago. A mathematician, Hungarian-American mathematician, who was dealing with those things. Now, if you want to generate a secure random number or secure random bytes in the web browser, you can use web crypto for that purpose. Okay? So it's called, you can see the code here in the middle, crypto get random values. And you can state the length of that random value in bytes down here. So if you want for example, 120-bit random number, you would state how many bytes would that be? 128 bits are how many bytes? Any guesses? I will say higher or lower. It's 16 bytes. Okay? A 16-byte random number would be 128-bit random number. Okay, so we have that first very important requirement. We need random numbers, truly random numbers, cryptographically secure random numbers. And then we have to choose an algorithm to symmetrically encrypt the files. Now, let's take as an example a very popular algorithm in a very popular mode. AES, Advanced Encryption Standard, in CBC mode, cipher block chaining mode. Now we have three things that we want to ensure, we said in the beginning. Confidentiality. Question to you guys, can AES in CBC mode ensure confidentiality? You say no? Yes? Not sure? I say yes. So if we securely distribute the keys and everything is okay with us using the algorithm, basically AES in CBC mode, the mode is very important, can ensure confidentiality. How about integrity? Can we make sure that if I encrypt something here, let's say I have distributed the keys before, you and me, we have both our keys, the same key, and no one else knows that key. I encrypt something here, and I send it over to you. If there is an eavesdropper in the middle, can they manipulate the data, or can they not manipulate the data without you noticing it?
They can manipulate, but if you uncode it, you won't get the correct response, right?
So you're right. I cannot ensure integrity. Somebody could manipulate the data on the wire. You would not notice, the decryption would not fail. There's no exception thrown or anything. You might get garbage, but it doesn't fail. And if I can't ensure integrity, I can't ensure authenticity neither, because if I can manipulate something, authenticity and integrity are screwed. I can't ensure.
But my question is, why do we need that encryption on the front end? Because if we have HTTPS, why do we need anything
now,
to do anything?
If somebody breaks into the server and breaches all the data that's on the server, they can still read the files. That's what you mentioned, TLS, transport security, is only encrypting the data on the transport layer. Okay. If it's stored somewhere on the server in the file system, it's unencrypted in a normal and usual file upload. Okay. So I want to make sure that even though the server is breached, I still am in control of the confidentiality of the data. Okay? You will see later. Okay, so AES in CBC mode is considered a secure algorithm in secure mode, but in fact it's not really. I'm going to show you why that is the case. So I echo some data, blah, 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 something, and then a new line, and then let's eat, comma, grandpa, into a text file. Okay. Now I use OpenSSL in the encryption mode. You see that it's encryption with the -e here, with just some key. And I use AES with 128 bits length in CBC mode, encrypt the data. Okay, just let's convert this binary data into hexadecimal data so that I can easier read it. Ciphertext.hex. So this is the encrypted data. Okay, cool. Now I will manipulate a little part over here and see what happens. First, I have to convert this back, the hex, into a bin file. And then again, I use OpenSSL in the decrypt mode, which you can see with the -d on the lower left. And then I open the plaintext. And what happens is, let's eat grandpa. There's no comma. You're supposed to laugh now, but I know this is really sad because we all were relying on AES CBC for authenticity and integrity, but in fact we're not. I feel you, okay? I feel you. We have manipulated the ciphertext without decryption failing. So integrity and authenticity are not ensured in this case, okay? Just keep that in mind. Now the solution to this would be using a cipher in AEAD mode. Authenticated encryption with associated data. That just means stuff is encrypted and there's an authentication code calculated at the same time. It's like using AES CBC plus HMAC, for example. And that message authentication code is appended at the end of the ciphertext. So there's also authentication. Now, if I manipulate something on the way, the data is manipulated on the way, and you decrypt it on the other side, decryption is going to fail because it's going to notice that something changed. Okay? So if you have the choice, take one of those two ciphers over there on the bottom, AES GCM, Galois counter mode, which is an AEAD cipher. Or if you're a crypto hipster, take Cha-Cha-20 Poly 1305, the most stupid crypto name ever. But it's a cool algorithm. It's very solid, okay? So if you have the choice, take one of those two. Cool. So we have the basic knowledge to ensure not only confidentiality, but also integrity and authenticity of our data. Cool. Now we want to encrypt the files in our browser using that knowledge. We already learned how to generate random keys, random numbers, truly random numbers in the browser. Now we want to learn how to encrypt data in the browser. Now, the first thing we need to do when we have this random key, that random number, we have to import that key first. You can see that down here. We use web crypto and the function import key. Okay? We take the raw key, and what we get back is a crypto key object. And that crypto key object we can use now to encrypt stuff. We can encrypt a string, we can encrypt a file, we can encrypt anything. So over here on the next slide, you can see that using crypto encrypt, we can use that secret key, and as an algorithm, as we saw on the previous slide, we choose AES GCM because that's an authenticated encryption with associated data, AEAD cipher, which is cool. All the others are not so cool, or many others are not so cool. Well, the same goes for decrypt. As you know, with symmetric encryption, like with AES, we use the same key for both encryption and decryption. That's what symmetric encryption is all about. We just say crypto.subtle.decrypt using the same secret key. So these are the JavaScript APIs that you can use to encrypt and to decrypt data in a web browser. Okay, so we basically know how to encrypt and decrypt stuff. We know which algorithms to use. We know which JavaScript APIs to use for that scenario. Now comes the harder part. We want to support big files. We want to upload and download files that are maybe 10 gigabytes in size or even bigger than that. Now that's a big challenge because you saw the API. I can only throw in all the data at once. If I want to encrypt a file, I have to take all the files and throw it in there. There's no way to stream stuff in and out of web crypto. Okay? So we will have to chunk that file. We will have to split it in smaller chunks and encrypt every chunk and then upload it to the server. Let me show you how we can do that. So I have this file that's maybe 10 gigabytes in size. I have an input element with type file. I drag some file on there. Now what I want to do is I first want to split this file into small chunks. In our case, we take chunks of 64 kilobytes. Could be anything else, could be 1 megabyte or smaller than that. Then I use the AES GCM algorithm in web crypto to decrypt that chunk. Then the resulting size is going to be 64 kilobytes plus 16 bytes. Where do those 16 bytes come from? Yes, that's the authentication tag at the end. AES GCM does not have any padding, so there's no padding coming to it. There's only the authentication tag. That little 128 bits or 16 bytes of data that ensure authenticity and integrity of the data. So the decryption will fail if something is manipulated on a wire. So this is how we're going to approach this. Now, let me tell you for the upload, the way to split files into smaller chunks is the file reader API that is available in any modern browser. You can see the call to the file reader API right here. And there's a function called file.slice. So I can just take that file from the input, slice it, take out a slice, and do something with it. There's not going to be the whole file in the memory of your browser, right? It's only that slice. The rest is going to be thrown away. So if I take the next slice, the old slice is going to be thrown away. So this way you can slice a file of 10 gigabytes or even more in size into small chunks without using 10 gigabytes or more of memory. So that's pretty cool. Okay? Now, if I call that slice function, I also add an event handler so that once the reading of that slice from the file system is done, a function gets called. So you can see that function here on the next slide. It's called read event handler. And what I do once I have this slice of my file of 64 kilobytes, I call the encrypt function down here, and then I upload that chunk. Okay? So on the server side, I will have to create an API where I can upload chunk after chunk. Okay? I cannot upload the file all at once. I will have to in this case, I have a REST API that just takes one chunk after the other. And in the URL, there's the chunk index at the very end. So it's upload file /0/1 and so on and so forth. Okay? Cool. Just one more note when it comes to encrypting files. So the encrypt function looks like this. Make sure to use a nonce. Nonce is short for a number used once. And make sure that the index of the chunk also is part of that nonce. That nonce is going to be used in AES as an initialization vector. So when I encrypt something with one key, and I reuse the same key in every chunk of my file, I will have to use a different nonce or different initialization vector for each chunk. Why? The reason for that is because there could be a file where the same content is coming over and over again, and even in the ciphertext, I will see it. It's going to be the same ciphertext over again. Okay? So in order for the ciphertext to change at every chunk, no matter if it's the same or different, I will have to use a different initialization vector for each time, every time I encrypt something. So the rule of thumb is, if I reuse a key, use a unique nonce or initialization vector every time you encrypt something. Okay? Don't reuse nonces or initialization vectors. Cool. So the file reader API is pretty well supported in all major browsers. Even Internet Explorer supports file reader API. It doesn't support read as binary string, but we're not using that anyway. In this case, we're not using it, so we can even upload files in Internet Explorer 11. All right? Cool. Now, it's getting harder and harder because download is even harder. The thing is, I want to stream the download. I want to click on a link. I want a save as dialog to pop up. And I want the contents of the file to be decrypted, one chunk after the other. And I want this to be streamed into my downloads folder. Now, the only way in a web browser to stream stuff from the download into your downloads folder is having an anchor element with a href equals something, and then you click on it. Okay? Now, this is something I cannot do, unfortunately. Now, if you look at I use Axios in this case. I just call the download to the file, and I say response type blob, which means I will have a byte array of the whole file in memory of my web browser. And then I could go ahead and say, I just chunk that file again, decrypt it, and then I create a save as dialog. I can do that, but that's going to use 10 gigabytes of memory times 2 if I have a file of 10 gigabytes. Okay? We will later see that we will still use this function for a different reason, but we cannot use it for big files. Now, that would be the way to have a decrypted byte array, and then you create a link in the DOM like this, append child, and then you click it programmatically. That's really ugly, isn't it? So that would be the way to create a save as dialog in your browser with just a byte array in your memory. But again, this would use a lot of memory for big files. So that's not what we're going to use. Okay. We cannot stream data. So what we can use now is service workers. Now it gets a little bit complicated, but still, once you've grasped the concepts of service workers, you're going to see how it's going to help us. Now, just a quick primer on service workers. Service workers are little pieces of JavaScript that run in the background of your browser, and they kind of act as a little proxy server between your website and your server. So you can, for example, intercept HTTP requests, do something with it, manipulate it or change it in a way, and then send it back. Okay? It runs in a worker context, which in a browser is a special context. There is no access to the DOM. So you cannot access the DOM of the website itself. You can only intercept requests and do something with it. Okay? So they're kind of limited in what they can do with your website. Some use cases of service workers. You could intercept and modify requests, as I just said, and this is also the feature that we're going to use to decrypt our files. You could also the primary use case for service workers is caching resources. You could use that to make your application a progressive web application, PWA, because you don't need internet to load the website. Okay, you could cache your JavaScript resources, your CSS, your images to load the site, and you can temporarily store something the user creates on the website, and then when the network is available again, you can upload the stuff. That's something that you can use service workers for. So PWAs make very heavy use of this concept. So if you want to have a look at how this works, maybe just visit the website that uses a service worker, and when you go to the application tab up here, this is a Chromium-based browser in this case, application tab up here, and then service workers here on the left, you're going to see that there's a service worker running in the background of this test application here. Okay? It's this little cogwheel icon that you can see that also will be in the network tab when the service worker is loaded. There's going to be a little cogwheel on the side of the file name. Okay, registering a service worker is pretty easy. What you do is navigator service worker register with the URL to your JavaScript file where the service worker resides, and it's going to load that service worker. Now, if you just want to cache resources, that's great if you just install the service worker, but the thing is when we want to decrypt files, we want this service worker to be available immediately. Usually it's only going to be available at the next page load. Okay? If you want the service worker to be available immediately, what you can do is inside the service worker, add 2 event listeners, one for install and one for activate, and just add these lines of code, and it's going to be immediately available. Just copy and paste this stuff if you want it to be available immediately. Okay, now let's have a look at how the download is going to work. I hope this is big enough for everybody in the last row as well. Now, here on the right-hand side, the right half of the screen is the service worker. So this is where our decryption stuff is going to happen. Now, as the service worker does not have any access to the DOM, we need to give the service worker the key to the file, which it's going to use to decrypt, in any other way. There are ways to communicate with your service worker, and that's going to work with navigator, service worker, controller, post message. Okay, I can post messages over to the service worker, and I can send the service worker the master key, which is what I'm doing right here. And in the service worker, I say on message equals and the function, I can take the master key. So when the user hits the download button of the file I want to decrypt it, first I send over the master key, and only then I'm going to load the URL. Now the third step, again, I create an anchor element and just programmatically click it in my web application. And here in the service worker, I have an onFetch method. So every time anything is fetched, or you click a link, or you use the fetch method, or you use XML HTTP request, or anything like that, that onFetch method here is going to fire. And I can go ahead and manipulate the response. Okay, what I do here is I respond with a stream, which is going to decrypt the data. And here's the function to decrypt that file, and it's going to go back to the web application, and the save as dialog is going to pop up. I have to do it this way because on the left-hand side, I have to create an anchor element with an href and click on it, because that's the only way to stream stuff into your downloads folder, as I said before. I cannot use fetch and then a blob and decrypt the stuff because I can't stream. That's the only reason why we're doing this. We don't want to hold the whole file in memory. That's why we need a service worker, so that we can act as if everything is normal over there on the left side. Okay? Service worker support also pretty good. With one exception, in Edge, in older versions, we cannot use this because readable streams, so the stream that I'm creating here, readable streams, native streams, are not available in service workers in Edge, only starting from version 79, where it's using the Chromium engine already. Okay? So with the current version of Edge, the current stable version of Edge, you unfortunately cannot use this method. So right now it's only for Firefox, Chrome, not even Safari. Okay, so just a very short primer again. This is very, like I said, you're going to see a lot of code, and you're going to see a lot of JavaScript, vanilla JavaScript APIs. The Readable Stream API is just a method to stream data. So you can take, for example, the result of a fetch call and stream it somewhere. You can chunk it into little chunks of data. You can decrypt stuff. You can pipe one stream through the other stream and stuff like that. So we need this to decrypt our data. So we have 2 transformers here. We take in the service worker, we call the fetch method to get the encrypted data from the server. Then we use a stream slicer to, again, chunk that big file into our 64 kilobytes plus 16 bytes of data. So we have those small encrypted chunks. And then we pipe it to the next transformer, which is the decrypt stream controller, which is going to decrypt the stuff and then send it back to the website. Okay? So that's what we can do with readable streams. That's how the decrypt stream controller works like. It's just going to call the web crypto API to use AES GCM to decrypt the data. Readable streams are also pretty well supported, but not in Safari, unfortunately. And in Edge, they are only supported within service workers starting from version 79, where the Chromium engine is going to replace the Edge HTML engine. So no native streams inside service workers here. Cool, so we are supporting big files. Okay, so we can stream stuff up to the server using the file reader API, slice it, encrypt it, and then upload chunk after chunk. And for downloading big files, we can use service workers readable stream to, again, chunk the stuff and send it back to the website. It's a bit complicated because for up and download, we're using completely different JavaScript APIs. Okay, upload is way easier than download usually. Cool, so we want to support old browsers as well, because we have seen that service workers and readable streams and all this stuff is probably not supported in older browsers like Internet Explorer and others. So for the upload, everything is okay because file reader is widely supported and it's easy to use, everything all right. The download is the more complicated thing. It requires service workers and native streams, which are not supported by many browsers. But we can use blob download. Remember what I showed you before? I can use the create object URL function over here with the result, with the decrypted result, and then I can programmatically click on that link. The thing is just it's going to be using a lot of memory in my browser. Okay, that's the only disadvantage. If you use Firefox 10 for downloading a file that's bigger than 256 megabytes, it's going to show you a warning in older browsers. It's going to say, this is going to use a lot of memory. You probably don't want to do this. Okay, just for that reason, they are doing the same stuff there because service workers are not available. So that's the warning that they show. This browser might not be able to decrypt a file this big, okay, for that reason. We can stream it in older browsers because of readable stream and service workers not being available. Cool, so for smaller files, we can also use this in older browsers. For big files, we have to use a modern browser. Now, one last part, securely distributing keys. So the requirement is I want to upload a file. I want to create a link. I want to send you guys the link, and you click it, and you can download the file. Now, when you open a link, parts of the link are going to be sent to the server, but I don't want the server to know that key. It's supposed to stay in my browser, and in the messaging, whatever method you're going to use, you send it via email or WhatsApp or whatever it is. Okay? How are we going to do this? So the key must not be transferred to the server. Let's have a look at the URL, because there's one special part in there that's not transferred to the server. Now we have the scheme, we have the domain, we have the resource path, the query, and then there's the fragment. What's the fragment used for?
Anchors.
It's an anchor, and what was, in the old times of the web before Vue.js came up and other single-page application frameworks, what was it used for primarily?
Navigation.
For navigation. So you could, for example, you could send a link to a Wikipedia article, the 10th heading down there. You could just create a link with an anchor element, and the browser would jump directly to that heading. Okay, it jumps to the object that carries the ID of that fragment. Is this fragment sent to the server? No, it's not. Everything else is sent to the server, but the fragment is not. It's going to stay on the client. So we can use that to transfer our keys. So if you have a look at, for example, I opened what I just said, Wikipedia page, and you can see that here is an anchor text saying features. So I'm jumping to the features section of the JavaScript Wikipedia article. And you see here in the path that the fragment is not transferred to the server. So it's secret to the server. Here you see it. OK, so we're going to use this to securely distribute our keys. Demo time. I'm going to show you an application where I implemented this, taking the basic concepts of Firefox 10. You can see the source code, and they're doing just the same stuff, using service workers, readable streams, and file reader API. And I just did basically the same application using Vue.js. So I have to log in. That's just my example account here. A concept called lockers, where the files are inside. So here I have this upload area where I can just click and upload a file. I'm going to open the network tab so you can see that the file is going to be uploaded in small chunks. So I click here. You can see it's uploading chunk after chunk because I first slice the file, encrypt it, and then upload each chunk. Now I can go over here and create a shared link to that locker containing the files. I copied that link to the clipboard. Just head over to another browser. And you can see I use the fragment right here. Here's the hash sign to separate the ID to that file from the key to the file. The key is not going to be transferred to the server. I have to unlock it with the password. And now if I click on this, I'm getting this open dialog, and I can save the file. Okay. So at the download, it's again, the download comes in one big chunk, but I'm slicing it back to the small encrypted chunks in my service worker. Okay. So if you want to hear more about the implementation of Vue.js and also state management and keys and stuff, just approach me after this talk. It's a little bit beyond of what I can fit into this talk here. But I want to do a little wrap up of what we'll learn today. So if we want to ensure the confidentiality, integrity, and authenticity when encrypting something, we have to choose the right cipher mode. It's not just AES is a secure cipher. It's considered a secure cipher nowadays, but it depends on which mode you're using. If you have the choice, don't use cipher block chaining mode or CBC mode, because as we saw, we don't want to eat grandpa. Use a different cipher that also ensures both integrity and authenticity. And one such cipher that is available and mode that is available in your browser in the Web Crypto API is AES GCM. It's an AEAD crypto hipster cipher. Very cool. If you want to use cryptography in the browser to generate random numbers, you can use the Web Crypto get random values function, which produces secure random numbers. It's going to access the operating system sources for secure random numbers. Okay, so if you're on a Windows or Mac or Linux machine, it's going to access the, at the end of the day, it's going to access the kernel function that generates random numbers. Use cryptosubtle import key to take such a random key and get a crypto key object, and then use cryptosubtle encrypt and decrypt to symmetrically encrypt and decrypt stuff. For example, files or file chunks. For chunked upload, use the file reader API. That's pretty easy to use and has very broad support. You can chunk stuff into small chunks and then upload it to your server. For chunk download, that's a little bit more complicated. You have to use service workers to do that in the background, and Readable Stream API to chunk stuff in the download. You can also support older browsers by just limiting the file size for old browsers. And you can use the blob download. Cool. So I just want to lose a word also about the Sec4Dev bootcamp. That's probably interesting to you folks because it's about single-page application security. This is Philippe Derek. He was our bootcamp instructor last year. He's one of the best tech instructors that I have seen in my life. He's really, really good. And he's going to give a bootcamp on single-page application security, where he talks about cross-site scripting, content security policy, and how to integrate this in your application. Also to understand cross-origin resource sharing, which is kind of hard to understand. Also JSON Web Token security and what this is all about, and so on and so forth. A 2-day bootcamp, the week after the next week, Monday and Tuesday. Just check it out on sec4dev.io. There's more. 3 other bootcamps and lots of talks that could be interesting. Thank you very much for listening and bearing with me, although there were so many code samples. Follow me on Twitter if you want to see more security-related content regarding software security, and I'm also going to publish a link to the slides up there. Thank you very much.